Welcome back, dear viewers. This is the last video in this particular series where we are going to train our AI model and then we'll classify the hard disk. So in the previous video, I have shown you that we have converted all the ECG signals into time frequency representation and they have been stored into their respective folders. So what we're going to do is first, we are going to load this scalogram images using an image data store. Image data store is a function that will help us in automatically labeling the images. So whatever is the folder name, the same will be the label names over here. When you have a large data which could not be fit into the memory, at that case, what you can do is you can try to use image data store over here. So let's try and execute this. Once you have loaded your what you can say the data into this all images variable, we can go ahead and randomly divide our images into two groups. So let me maximize this. So what we are going to do is we are going to split this in a ratio of 80 to 20. And how we are going to do that? So 80% goes to IMGS train and the remaining part goes to IMGS validation. You may also notice one more thing over here, that I do not have over here other images. So this is 130 images for training and 32 images for validation. Now it's the time when we can go ahead and decide which particular neural network we are going to use over here. Now since in the initial videos we discussed that this data set is unbalanced and the data set is not too large, what I can do is I can go ahead and use the transfer learning approach. So in this case we are going to use SqueezeNet, right? So if I load SqueezeNet, you'll find out that the input layer has a dimension of 2 to 7, 2 to 7 by 3. So what we are supposed to do is, whatever time frequency images we have to take care that these images are also of the size 2 to 7, 2 to 7 by 3. And for this, what we can do is, we can use this augmented data store. Once this is ready, we can go ahead, go to Deep Network Designer app. So what we'll do is we'll go to app. In this app section, if you go to the machine learning and deep learning section, you can type in over here Deep Network Designer app. Click on this Deep Network Designer app. And what we can do is we will try to modify our SqueezeNet as per the number of classes that we have. One another way of doing this is that you can also try to load the model, okay, programmatically. So we are going to use a low code no code approach. Once my Deep Network Designer app is loaded, you can observe over here that it provides us different options. We are not going to train a neural network from scratch, so we are not selecting this blank network in a case. We will be trying to use SqueezeNet or GoogleNet. I'm trying SqueezeNet over here, so let's click on open.